Right, having refreshed our minds on flux, let's talk about intensity. The flux is a measurement of all the rays that pass through a given area. A more fundamental description of the radiation field should consider the energy coming from individual rays. If we're dealing with quantum mechanics, we would mean a single photon. But, as we said, the theory of radiative transfer is a classical theory describing radiation fields in a microscopic way. We wish then to consider the energy in a single ray of radiation. Yet, a single ray cannot be isolated. What we measure is a set of rays. That means a beam. So we can construct a beam considering a set of rays that differs slightly from a given ray. For that, we can construct an area S that is normal to the direction of the ray. The ray we're considering is the black line, the black arrow. And consider all the rays that pass through the area S, whose direction is within a solid angle omega of the given ray. So this beam will contribute an amount of energy at the detector related to the size of this solid angle. Now, the radiation field may be non-uniform inside an extended beam. So we're going to consider an infinitesimal solid angle within which we can consider the illumination to be uniform. If we consider an infinitesimal beam, we can write the proportionality that the energy is going to be proportional to the area, to the time, and to the solid angle. Notice that in this equation here, dA is the area of the detector and the omega is the solid angle of the beam. They're both vectors pointing to their respective normals n and n prime. So you can have here either this being a source, so the normal is pointing toward this direction, and this source is emitting a ray into this direction here, into this solid angle. Or conversely, that if this was inverted ray, so going in, the ray would be coming from this direction, from the solid angle, and into the area that in this case would be the detector. So because the normals are not aligned, right, you consider this angle between them, and that mathematically is the dot product that appeared in the definition. So we can write dA equal to n hat times the scalar dA, and the omega being equal to n prime times the scalar d omega. So this direction would be the direction of n hat, and this direction is the direction of n hat prime. So that this dot product is intuitive. A ray that is grazing the detector, that means that is perpendicular to the normal to the surface of the detector, is not going to be registered. Now, if we define theta being the plane angle between n and n hat prime, then we can define the energy as n hat dot n hat prime dA d omega dt in terms of the angle. So we can define the disproportionality as the intensity. And as was done for the flux, we can also define the specific intensity as the intensity in a frequency range. We're isolating I nu. So the dimension of intensity is energy per time, per area, per solid angle, per frequency. In CGS unit, that means erg per second per square centimeter, per hertz, per sterradian. The sterradian is the unit of solid angle.